Hello, Matinix. I'm Starra Rapal.
I'm Juna Louise Alaba.
And I'm Mea Frich Yamut.
Your Matinic tutors.
In today's episode, August 24, 2019, we're live at USTP. And now, you will learn about the basic mathematical logic that is needed in every field of study.
We will talk about what statements are and the techniques on how we can determine the truth value of compound statements.
Let's start. Here are some of the mathematical terms that you need to know for our lesson. A statement is a declarative sentence that demonstrates the truth of certain statements. A compound statement made up of two or more statements with connectives such as and, or, not, if, then. An antecedent is the first half of a hypothetical proposition or the statement P. A consequent is the second half of a hypothetical proposition or the statement Q. There are five logical operators that we will focus on. First is conjunction. In symbols, it is written as P with caret Q, which is read as P and Q. In this case, when both P and Q are true, only then the compound statement is true. Otherwise, it is false. Since both P and Q statements are true, then it is true. Always remember that if P and Q statements are true, then P and Q is true. Otherwise, P and Q is false.
Second is disjunction. In symbols, it is written as P with the upside down caret Q, which is read as P or Q. In this case, when both P and Q are false, only then the compound statement is false. Otherwise, it is true. For example, let P represent 18 is an odd number, and let Q represent 8 is greater than 10. Since both statements are false, then its truth value is false. Always remember that the only way for a disjunction to be a false statement is if both statements are false. Otherwise, it is true. Third is negation. It is the opposite of the given proposition P. The symbol tilde is used for not, which is read as not P. One way to form negation of a proposition is by employing the word not. You just have to remember that if P is true, then not P is false. And if P is false, then not P is true. For example, let P be a proposition, today is Saturday. So the negation of the statement is today is not Saturday.
Part 1 is conditional statement. It has a symbol P implies Q. The idea of this statement is whenever the P, which is antecedent, is true and Q, which is the consequent, is false, then P implies Q is false. Otherwise, it is true. Now let's go on to the truth table. The variables that we have are P and Q. So for the P, it has the possibility of true, true, false, false. For the Q, it has the possibility of true, false, true, false. Let's go back to the idea of this condition. It can only have a false possibility if P is true and Q is false. On the table, the only one who has this condition is the third row. So that means that it is the only false, and the remaining are all true. For example, let P, Jane is singing, and let Q, she is happy. Let's apply the conditional statement. If Jane is singing, then she is not happy. It is false because P is true and Q is false. The last one is by conditional statement. It has the symbol P if and only if Q. The idea of this statement is whenever both P and Q have the same truth values, then it is true. Otherwise, it is false. Now let's go on to the truth table. We have the variables P and Q. P has the possibility of true, true, false, false. Q has the possibility true, false, true, false. Then going back to the idea of this statement, we can only have true if both P and Q have the same truth values. Looking at the table, only first and fourth row have this condition. So that means that these are the only true, and the remaining two are false. For example, let P, Jane is singing, and let Q, she is happy. Let's apply the biconditional statement. Jane is singing if and only if she is happy. True because both statements are true.
That's the end of our discussion.
We hope you have learned something in this episode.
Thank you for listening.